students, kamusta? I hope that you are all doing good and safe, especially that we are still in the midst of the pandemic. And by the way, this is your teacher, Teacher Ralph. So are you ready for today's lesson? I bet that you are. But before anything else, let's have a game first. Hello there, I hope you enjoyed at the same time got thrilled from the short game that we had, which is the Flappy Bird. However, the game has been removed already from both Google Play and App Store because of its addictive nature. And just a quick fact, because it has been overused worldwide. Out from the game that we had, what do you think would be our topic today? I know that there are lots of ideas creeping in your head at the moment. Don't worry, let's check it out. So to proceed to our lesson proper, I'll switch over to my phone. I'll see you in a bit. Good day everyone, so welcome to lesson 1.1. The topic is all about the introduction to direct variation. But before we delve to this topic, let's get to know first our learning objectives so that we will be provided with a clear purpose on which to focus towards learning this lesson. So at the end of the lesson, you will be able to illustrate situations that involve direct variation without error, translate into variation statement a relationship involving direct variation with 95% proficiency level, solve problems involving direct variation. I'll expect this from you students, okay? Now, what is a direct variation? Do you have any idea about what this thing is? Okay, first let's have these application of direct variation as you can see here. Now look and reflect at these two pictures where we could possibly apply direct variation. For example, in the number of men at work. If there are more persons doing the work, then there would be more work done. Now, the same respect we could give if there are lesser men at work, then there would also be lesser work done. So this is an example of direct variation. Now, let's go back to the short game that we had. So how does the game Flappy Bird relate to the concepts of direct variation? We all know that in this game, we need to help a paper bird fly through the obstacles for as far as possible. You may get bonus score when you pass the obstacle at the designated place. If you hit the obstacles, the game is over. The game Flappy Bird relates to the concepts of direct variation because the more obstacles you pass through, the higher would be your score. Therefore, direct variation is a relationship between two variables, let's say x and y, that can be written as y equals kx, where k must not be equal to 0. In direct variation, we make use of the equation y equals kx. This can also be read as y varies directly as x, or y is directly proportional to x. Some would also say y is proportional to x. So the variable that appears first in any direct variation statement, in this case, we have y. This will be isolated in a particular side of our equation, as you can see here. And then the second variable that will be mentioned or stated, in this case, we have x. This will be multiplied by k. Now, what is k? So the k is the constant of variation or the constant of proportionality that relates the two variables in our equations, which are y and x. For example, let's set k, or the constant of variation, into 2. And then we have given values of x, which are 1, 3, and 5. Let's use k and the values of x to find for the unknown values of y. So by using this equation, y equals kx, we will substitute the value of k, which is 2, and then the values of x. So in the first row, k will be substituted by 2, and then x will be substituted by 1. So y is equal to 2 times 1, so the answer would be 2. In the second row, the equation will become y is equal to 2 times 3, because the values of x is 3. So y is 6. In the third row, x is 5, so the equation will become y is equal to 2 times 5, which is 10. As you can notice in our table of values, the increase in the values of x led to the increase in the values of y. Now, when we divide the values of y, let's say 2, by the corresponding values in x, which is 1, then the answer would be 2. When y is 6 and then x is 3, then 6 divided by 3, the answer would also be 2. And then when y is 10 and then x is 5, then 10 divided by 5 equals 2. So in order to find for k, or the constant of variation, we will just divide y by x. Therefore, the formula to get the constant of variation would be k is equal to y all over x. Again, for two quantities with direct variation, as one quantity increases, the other quantity would also increase. Let's proceed to translating variation statements into mathematical equations. Let's translate each statement into an equation. We're going to use k for the constant of variation. Number 1, the fare f of a passenger varies directly as the distance d. This will be translated as f is equal to kd. As you can notice, the first variable that we mentioned is f. Therefore, f is isolated at the left side of the equation. And then the second variable, which is d, is to be multiplied by k. And then k is equal to f all over d. Number 2, the cost c of fish is directly proportional to its weight in kilogram. This will be translated as c is equal to kw, where k is equal to c all over w. Number 3, the wind's pressure P on a flat surface varies directly as the square of its velocity, v. This will be translated as P is equal to kv squared. As you can notice, the first variable that we have mentioned has been isolated at the left side of the equation, while the second variable b, we square it because according to the statement, the square of its velocity. That is why we square v squared and then we multiplied it by k, where k is equal to p all over v squared. Okay? Number 4, the rate r of flow of water through a pipe varies directly as the square of the radius r of the pipe. This will be translated as r is equal to k r squared. As you can notice, we squared the r because the statement says the square of the radius. We multiplied it to k, and then the rate is isolated at the left side of the equation, where k can be solved using the formula k is equal to r all over r squared. So these are few of the examples in translating statement into equation of variation. So at this juncture, let's go to solving problems involving direct variation. Let us now apply our skills in recognizing pattern and knowledge in formulating equation in solving problems involving direct variations. So try to consider this problem. Ted uses 20 liters L of gasoline to travel 200 kilometers D. How many liters of gasoline will he use on a trip of 700 kilometers? So we will solve this problem in a step-by-step basis so that we can easily visualize or internalize how it works. So step 1, write the correct equation. We all know that direct variation problems are solved using the equation y is equal to kx. In the given problem, y is represented with d and x is represented with L, since the two quantities show direct relationship. Therefore, our equation now becomes d is equal to kl. So let's proceed to step 2. Use the information given in the problem to find the value of k. In this case, you need to find k when x is 20 and when y is equal to 200. So in order to find for k, we can manipulate the equation 200 is equal to k times 20 by multiplying both sides of the equation by 1 all over 20. So 200 times 1 all over 20 is 10. And then, k times 20 multiplied by 1 all over 20. So 20 here will be cancelled out and cancelled out. So the remaining term is k. So 10 is equal to k. Therefore, we now have the value of k, which is 10. We can now proceed to step 3. So we write the equation from step 1, which is d is equal to kl, by substituting the value of k in step 2, which is 10. So the equation d is equal to kl will be rewritten as d is equal to 10l. Okay? So step 4. Use the equation found in step 3, which is d is equal to 10l, and the remaining information given in the problem to answer the question asked. In this case, you need to find for L when D is 700. So the equation now becomes 700 is equal to 10L. Let us manipulate the equation by multiplying 1 all over 10 to both sides. So 700 times 1 all over 10 is 70, and 10L multiplied by 1 all over 10. So 10 here will be cancelled out and cancelled out. So the remaining term is L. So 70 is equal to L. Therefore, Ted needs 70 liters of gasoline on a trip of 700 kilometers. Problem number 2. Let us consider this statement. If x varies directly as y and x equals 9 when y is equal to 6, find x when y is equal to 16. We can solve this using these steps. Step 1. We need to write the correct equation. Again, direct variation problems are solved using the equation y is equal to kx. So we will write here step 1, y is equal to kx. Let's proceed to number 2. Use the information given in the problem to find the value of k. In this case, you need to find k when x is 9 and y is 6, right? So let us write the equation from step 1, which is y is equal to kx. We will substitute the values of y, which is 6, and the values of x, which is 9. So the equation now becomes 6 is equal to 9k. We can solve the values of k by multiplying the equation, both sides of the equation by 1 all over 9. So we can also solve this using the division property of equality, but we use the multiplication. So 6 times 1 all over 9 is 6 all over 9. And 9k times 1 all over 9, we can cancel this out, the 9, and the 9 here is also cancelled out. That is why the remaining term is now k, because k times 1 is k. So 6 all over 9 is equal to k. That is why we can simplify 6 all over 9 by dividing both sides by 3. So 6 divided by 3 is 2. All over 9 divided by 3 is 3. So our k in simplified form has the value of 2/3. Okay? So our k is 2/3. So let us proceed to step 3. We need to rewrite the equation in step 1, which is y is equal to kx, by substituting the value of k in step 2. So in step 1, we will just substitute the value of k, which is 2/3, in this equation, y is equal to kx. That will be for step 3. So the equation now becomes y is equal to 2/3 x. Right? Did you get it? So step 4. Use the equation in step 3. So we will use this y is equal to 2/3 x and the remaining information given in the problem to answer the question asked. So in this case, we need to find x when y is equal to 16. So the equation now becomes y is equal to 2/3 x. We can now find for x when y is equal to 16. So substitute y by 16 is equal to 2/3 x. Again, we can find for x when we manipulate the equation by multiplying both sides of the equation by 3. So 16 times 3 is equal to 48. And then 2/3 x times 3. So we can cancel this out, 3, and then this 1. So the remaining term is 2x. And we can apply the division property of equality by dividing both sides of the equation by 2 so that we can retain x. Okay, so 48 divided by 2 is 24, and then 2x divided by 2, cancel 2, we can cancel this and this one, so the remaining term is x. We have now the value of x, which is 24. Alright? So this is how to solve 4 problems that involves direct variation. So this time, let us assess your comprehension. It would be better if you answer this right after you have watched the discussion so that the learnings are still fresh. Okay, number 1. The area of a square is proportional to the square of its side. Translate the direct variation statement into mathematical equation. Number 2. If y varies directly as x, and y equals 12 and x equals 4, find the value of y when x is equal to 12 and the equation of variation. Number 3. Every 3 months, a man deposits in his bank account savings of 5,000. In how many years would he have saved 250,000? So pause this video and answer the following. So that would be all for today's lesson. Thank you, students, for watching. For more questions and clarifications, you can visit this link I posted here. So I hope that you have learned something today. God bless us all.